Your attitudes, beliefs, and intentions are not your own. Your mind is bombarded by a ton of social information throughout the day. Neuroscience allows us to investigate what happens in the brain when we think about and interact with other people, and how we come to resist and adopt new ideas. We are here in Amman, Jordan, to investigate how the mind behaves under conditions of sectarian pressure. In this study, we have recruited subjects that are highly sectarian Sunnis or Shias from Iraq. We will bring one from each sect into the room and place them on either side of the dividers, and we will have them listen to a message regarding a sectarian topic of political interest that is either argumentative or conciliatory from the other person's perspective. So the Shia would listen to a Sunni message, the Sunni would listen to a Shia message. They will be listening to them on headphones, and then we will remove this divider and have them work on a task together. After working on the task, we replace the divider, and they then listen to two news clipping. One is biased towards a Sunni position, the other is biased towards the Shia position. During this time, we have a portable neural imaging system, functional near-infrared spectroscopy, and it creates detectors that go on a cap that is affixed to their head. There are light emitters from LED lights and light detectors that detect oxygenation levels in the brain, which is an indicator of brain activity. We have two of these systems that are set up to a computer that records brain activity while they are responding to the various stimuli. As expected, we find positive correlation between the political position and sectarianism, and we see a negative correlation between sectarianism and affinity towards their partner of the other sect. Neural data is collected from both subjects simultaneously so that we can observe correlations between neural patterns in response to similar stimuli or their interactions. Subjects spent on average 5.5 minutes doing their joint resource allocation task together. With data collection complete, there are many things we can explore. Make careful note of the probe montage, which will indicate which FNIRS channels correspond to different areas of the brain. You can then analyze data using Excel, R, Python, or a software of your choice. I'm going to highlight a few of my findings. There's only one region correlated with compromise, measured as the distance from individual baseline to the joint task solution. The region is in the left dorsal medial prefrontal cortex, which is associated with emotional regulation and managing complex social relations. Several brain regions are negatively correlated with self-reported affinity. These brain regions have previously been found to be involved in dealing with social conflict and negative affect, so it is consistent. This study provides insight on cooperation, compromise, and affinity. In many ways, it confirms what we already know about human behavior, but it also provides us a tool to measure the brain and shed light on interacting processes. Is there counter-arguing in response to your argument or the way you're presenting the data? Or is it the result of existing biases that are harder to overcome? And if we design interventions to try and overcome these biases, how do we know that they're working? And how do we know how they're working? Neuroscience is a powerful scientific approach for not just measuring the brain, but also reasoning about human behavior. Until next time, I'm Dr. Ian McCullough. Thank you for joining.